Congratulations, you've made it to lesson 3, and this is the last lesson in our review unit. We're going to be graphing linear equations and connecting the equation with the graph and with a table. We're even going to connect those things with a verbal description of a linear scenario. Our favorite form of a linear equation is the slope-intercept form, which looks like y equals mx plus b. The y is by itself on one side of the equation. There's nothing added to the y, there's nothing multiplied to the y. Y is all by itself. And then you have a number multiplied by x. Now if there's no number in front of the x, then that just indicates an understood 1. So you can have 1x if you have x all by itself. And then plus b, and b does not have a variable with it. The m and the b in this equation are just standing for numbers. Okay, so the m, the number in front of the x, is the slope of our line. The b is the y-intercept for our line. Another way to say slope is to call it the rate of change. So how fast are the variables in our scenario changing? Okay, and then the y-intercept sometimes is referred to as a starting point. And when we're graphing, we're going to start with the y-intercept because it's the easiest way to graph. So let's look at our first equation and let's graph it. Y equals 1/3 times x minus 4. So first I want to identify my slope and my y-intercept. The slope is the number that's multiplied by x, so in this case 1/3. The y-intercept is the number that doesn't have a variable with it, so -4. Notice I'm taking the minus that's in front of the 4 and changing it to a -4, so that when I graph, I'm starting at the right place. I'm going to start with the y-intercept. So our x-axis is the horizontal axis and our y-axis is the vertical axis. Where they cross is the origin. So I'm going to start at the origin and I'm going to count down 4. So 1, 2, 3, 4. And since I'm going down, that's a negative direction and that puts me at -4. This is my starting point for counting my slope. My slope is 1/3. Slope is rise over run. You've heard that before. Slope is how fast are your y values changing as your x value changes. So I'm going to change in a y direction first, and then I'm going to change in an x direction. My y direction is going to change by 1, so starting at my y-intercept, I'm going to go up 1, and then let me change colors on this. So you can see from the -4, I go up 1, that's a y direction, and then I'm going to go 3 in the x direction, and then I'm going to put a point there. That next point is on my line, and I can repeat that process. I can go from that point up 1 and to the right 3, and that puts another point that's on my line. Now I don't have to go up and right. Instead, I can start with my y-intercept and I can go down 1, which is a negative direction, and I can go left 3, which is also a negative direction, and that also gives me a point that's on the line. Now you only need 2 points to draw the line, but we want to do a couple of extras just to make sure we understand that slope. Let's grab a ruler or a straight edge and let's sketch that line in there. Notice when I draw my line, I'm drawing it edge to edge on the grid. I'm not just drawing a short segment right in the middle of it. I want to make sure I give a clear indication of what this line is doing, and it's going to be changing at that same rate all the way across the grid. Go to the next grid and you see that you don't have an equation, so I want you to write this one in. Y equals 3/5 times x plus 1. So if we identify our slope, we can see that it's the number in front of the x. The x just kind of tells us where that slope is. The x is not part of the slope. And then our y-intercept is the other number. This is a +1, so my y-intercept is going to be at 1. And that's where I want to start, at b equals 1. On my y-axis, I count up 1, and I put a dot, and I'm counting my slope from there. So I'm going to go, in the y direction, I'm going to go up 3. And in an x direction, I'm going to go to the right 5. So from the y-intercept, up 3, and then to the right, 1, 2, 3, 4, 5, and put a point there. Then maybe I want to go in the other direction, go back to my y-intercept. I'm going to go down 3, and then I'm going to go to the left 1, 2, 3, 4, 5, and put another point there. And then we'll use a straight edge to draw that line. So I'm using a straight edge to draw the line so that it's nice and neat. It's important that you're showing me these points on your graph. So use a straight edge if you need to. Sometimes you can draw a straight line without needing a straight edge, but make sure you're indicating those points of counting the slope. If we look at both of these lines, they both are uphill lines. If I'm looking at them from left to right, they're going uphill this way, uphill this way. And the reason that's true is because our slopes were positive in both situations. In the first graph, we had a slope of positive 1/3. On the second graph, we had a slope of positive 3/5. And that's why we have a line that is uphill. Let's go to our next equation, y equals 2x minus 3. You can see that the slope is 2, and you think, uh-oh, that's not a fraction. I need a fraction for the slope. But we can make any number into a fraction by putting it over 1, and that's all we have to do here. And we're going to choose our y-intercept, which is negative 3. Remember to take that sign with it. So we start at the origin, and we count the y-intercept down 3 from there at negative 3. And then from that point, we're going to count our slope up 2 and over 1 gives us another point, and from there up 2 over 1 gives us another point, and we could count backwards as well, down 2, left 1, and put a point there, and that's enough to give us a line. On our next equation, y equals negative 1/2 x minus 1, so when we identify our slope, we're going to take that negative in front of the 1/2 as part of the slope, and then the y-intercept is at negative 1. So we're going to first plot the y-intercept from the origin, go down 1, and then if you think about that fraction, remember what we talked about in a previous lesson, the negative can be in front of the fraction like it is in the equation, or we can put that negative in the numerator, or we can put the negative in the denominator. It really doesn't matter where that negative is. You just need to go a positive direction and a negative direction to have that negative slope. So I'm going to start at my y-intercept right there, and I'm going to go up 1, which is a positive direction, which means I need to go left 2 for that negative direction so that I have a negative slope, and I'm going to put a dot there, put a point there, and then I'm going to go up 1 and left 2 for another point. Now instead, I could have started at the y-intercept and I could have gone down 1, which takes care of the negative, and then to the right 2 and put a point right there, and you can see that all of these points are in a line. You can also see that when I draw my line in there, it's going to be a downhill line instead of an uphill line. So I'm not using my straight edge here. It's not quite as straight, but I've got my points in there so that you can see my slope. And you can clearly see that from left to right, I have a downhill line, and that's because I have a negative slope right here. So that's always a good check when you're graphing lines, to make sure that your slope and the direction of your line agree with each other. On your paper, there are no equations for the next 2 grids, so make sure that you write these equations in. Then pause the video and try graphing them on your own, then continue the video to check your answers. Make sure you pause the video. Alright, we're back. Do your graphs look like this? Notice the y-intercept on the first graph is at 2, and then since I have a slope of negative 4/3, I want to go down 4 and to the right 3, or maybe I went up 4, which is positive, and left 3, which is negative, but I get that downhill line because of the negative slope. Now the next one's a little bit tricky because I changed the order on you, right? The 3 doesn't have an x on it, which means that that is the y-intercept, and the number that's in front of the x, including the sign that's in front of that, is the slope. So the slope here is negative 4. So when we say y equals mx plus b, you can change the order of those terms and you get the same equation. So if I wanted to actually rewrite it, I could write y equals negative 4x plus 3. So my y-intercept is 3 and my slope is -4. Remember, think of that number -4, make it a fraction by writing it over 1. So from my y-intercept at 3, I go down 4 to the right 1, negative over positive, or I go up 4 over 1, positive over negative. Turn your paper over and let's look at some special cases. So one special slope is going to be, what if we have a 0 slope? What does our line look like? Well, we know that the slope is the number in front of x, so my equation is going to look something like y equals 0x plus, and then a number, we'll just say 4. 0 times x is just 0, so I could simplify this equation and call it y is equal to 4. So I know my y value is 4, my y-intercept is 4 from this version of the equation, so I'm just going to plot that, and then I have no change, right? That means y is always 4 no matter what x is, so that's going to give me a horizontal line because x can be 3 and y is still 4. X can be 10 and y is still 4. So that gives me a horizontal line in this direction, and same thing is going to happen when you go in the negative direction. So when you have an equation of the form y equals a number and there's no x in it, then that just indicates a horizontal line at 4, or in this case at 4, whatever that y equals value is. The other special case is an undefined slope. If the slope is undefined, it means that we're trying to divide by 0 for our rate of change, and you know that we can't divide by 0. Now in an equation that looks like x is equal to a number, we'll say x is equal to 3. So I don't have any y values specified in this equation. I only know that x is 3, which means x is always 3. So remember, your x-axis is horizontal, so I'm going to go over to 3, and I'm going to just put a dot, put a point on that x-axis at 3. But x is always 3, no matter what the y value is. So x is going to be 3 here, it's going to be 3 here, and here. And I could just go in, and I could fill in x equals 3, and you get that vertical shape there. You get that vertical line. So anytime you have an equation that has x equals a number and there's no y value, then you have a vertical line, and you have an undefined slope. Now what happens if we're given the graph of the line and we want to write the equation that goes with it? We're just going to work backwards. We want to look at our y-axis first and see what the y-intercept is. In this case it's 5. So in my template for my equation, y equals mx plus b, I know that y equals is not going to change and my b is going to be a positive 5. Now I need to look on that line to see where it crosses the grid again, and it looks like it crosses right here. So let's count that triangle. It's a downhill line, so we know we have a negative slope. From the y-intercept we're going down 1, 2, 3, and we're going to the right 1. So my slope is -3 over 1 times x. Now we don't usually write our numbers -3 over 1, so we'd probably simplify that to y equals just -3x plus 5. On the next graph, again, we're using that template, and we're going to pick out our y-intercept, which is at -1. So in this case, I know that plus b is going to be -1. And then I want to look on the grid until I see where it crosses the grid again, and it doesn't cross again until we get right there. So that's going to give me my slope. I'm going to count up 1, 2, 3, and over 1, 2, 3, 4. And this time I have an uphill line. Those are both positive directions. So my slope is 3/4. And I keep my x from my template, and that gives me the equation of that line. Again, we have a vertical line over here. I can see that x is equal to 3. Where does it touch the x-axis? Right there. So x is always 3. Let's put it all together. We have a verbal description. Bob has 3 cakes. That's the starting amount, so that's going to be our y-intercept. So we're going to have a plus 3. He bakes 5 cakes every 2 hours. That's 5 cakes per 2 hours. So that's our slope. 5/2 x plus 3 is our equation. fill out your table and graph it just like we have in the previous lessons and this lesson. And then in your summary, I want you to tell me why only part of the graph and part of the table makes sense for the problem.